Alright, in this video I'm going to show you how to create a quadratic equation, the parabola, okay, and we're going to find the y-intercept. The y-intercept is the c right here, so if you want to graph it, great. If you don't, that's okay also. So I give you the roots of 2 plus I and its complex conjugate of 2 minus 8i. Alright. And then we are going to FOIL this thing after we find the factors. So here we go. I wrote it down. Alright. I'm going to take these two to the other side. So I have x minus 2 minus 8i. Alright. That is equal to 0. And then I'm going to take this to the other side and I have x minus 2 plus 8i. Alright. And now that is equal to 0. I'm going to FOIL these. Alright, so they are both equal to 0. Now note, the conjugates, these two, the imaginary numbers are opposite because the i's got to cancel out, and the reals are the same. Okay, and then the x's are the same also. Alright, so now I want to FOIL this thing. I'm going to box it, multiply it together. Alright, and I have x minus 2 minus 8i. And x minus 2 plus 8i. Alright, so that's x squared minus 2x minus 8xi minus 2x. 2 negative 2 give me a positive 4. Alright, and then this is going to be positive 16i. Alright, this is going to give me a positive 8ix. Or xi, whichever, but they are going to cancel out. These two are like terms. These two boxes are always going to cancel out, okay? And then this is going to give me a negative 16i. These are going to cancel out. They're always going to cancel out. Don't just cancel them out. Check, all right? Check to make sure that they are adding to 0, these two and these two. If they're adding to 0, you are doing it right, okay? And then positive and the negative, give me a negative. 8 times 8 is 64, and then this is I squared. Remember, I squared is negative 1. Now, of all that I stuff we've been doing, this is the most important thing. So this is negative 64 times the negative 1. Alright. And 2 negatives make it positive, so this is plus 64. Alright. So these two are going to add up. 64 plus 4 is 68. Alright, so it's x squared minus 4x plus 68. There is your y-intercept. Alright, that is the y-intercept. So I went to Desmos. Alrighty, and there we go. I just graphed it for you. Alright, and you can see the visual right there, 68, which is what I had right there. And so also you can see that it never touches. There it is. In 68 units up, it never touches the x-axis right here. Thus, the roots are complex. All right, the roots are complex, and I state in the notes. Oops, wrong notes here. I state in the notes that something has to make up these complex equations. All right, usually roots will make them up right here, like these. The real roots, alright, but this is where it crosses. This doesn't, so we created something that does, alright. So I wrote this analogy out. Please feel free to read it. It relates spackle to sheetrock as complex roots, alrighty. So I'm going to do another example in just a second. Alright, so now we're going to do it again. The y-intercept we're looking for after we put these two roots together. Oh my, look at that. We got a fraction and everything. So let's go to my page right here. Alright. First thing I need to do is cross multiply. I'm going to take the 3 and move it up here. So I have 3x is equal to 11 plus 10i radical 6, and 3x equals 11 minus 10i radical 6. It's complex conjugate. Now I'm going to move these over. And I have 3x minus 11 minus 10i radical 6. And I'm going to have 3x minus 11 plus 10i radical 6. All right. Again, the imaginaries need to be opposite because they're complex conjugates, and the reals have to be the same. All right. And then 3x. All right. So make this a little bit bigger because I'm going to have more room to. It doesn't matter what goes on top. Okay. And then I have 3x, negative 11, 10i, radical 6. All right, 3 times 3 is 9, so that's 9x squared. Then I have negative 33x. All right, and then this is 3 times negative 10 is negative 30, I radical 6. Oops, 30x, the next in there. Then we have negative 33x, and I have 121, that's a positive 121, 11 times 11. Then I have a positive 110, I radical 6. Okay. Then I'm going to have a positive 30 I x radical 6 or xi, whichever. Positive, negative, they cancel. Then I have a negative 110 I radical 6. Positive, negative, they cancel. Now I got 10 times negative 10 is a negative 100. I times I is I squared. That's going to be that negative 1. All right. And radical 6 times radical 6 is 6. All right. So this is negative 100 times negative 1 at I squared times 6. So two negatives make a positive. So that is 600. So this is 600. All right. 600 plus 121. These two boxes are going to add up. All right. That's going to be 721. So I have 9x squared minus, that's 33x, minus 66x plus 721. Alrighty, let's go graph it and show it to you. As you can see, I typed it in, and that's where it crosses at 721. And we can see right there it goes no lower than 600. Alrighty. And so thus it has those complex, ugly complex numbers that we saw. Alrighty, on to the last problem. Alright, this is using the distance formula. Alright, I have two problems on these things, and that is finding the conjugates, which is pretty easy, and the distance formula. Alright, so we have this one. Let's put this in, put it into GeoGebra, because GeoGebra knows complex variables. So now I just send it into the complex. Alright, it's on the complex plane. And where am I here? This. And that's that. So it wants to know the distance between these two. Well, do it easily. Now, I'm telling you, you got to know this for the ACT. Some ACTs, they pop it on here. But we don't mess with it in this class, okay? So this is a geometry distance formula. You know it or not, it's on your ACT test. Real quickly, I need you to know the geometry of this. So we're going to draw a line segment. And go back to your algebra. There's your distance at 5.66. I think I told you to put it into tenths, so 5.6, 5.7. Pretty simple. All right, just plot the points and then go to the line segment. That's in Tools, Line Segment, and draw it together. All right, we've done the line segment. Make sure that you set your GeoGebra up right so that line segment shows up. Okay. One thing I do want to show you are conjugates. Conjugates are always on top of each other. I have a question on that. It's pretty simple. But let's say we have 1 plus 5i. Oops, I typed something in wrong. Let's say 1 plus 5i. Okay, so I'm going to type in its conjugate. Its conjugate would be 1 minus 5i. So I want you to see the geometry of the conjugates. Conjugates are always on top of each other. One's above the x-axis, the other's below the x-axis. And as you can see, this is 5 above because it's 5 positive, and this is 5, negative 5, so it's down below, and 5 plus 5 is 10. So the distance is always the two imaginary conjugates added together, and voila, right there. So when you get that conjugate problem, just add them up. You don't even have to graph it. 5 plus 5 is 10. I'd rather you know that. All right, thank you.